Buddy, welcome to Smallstep's webinar today. I'm Hunter Hawk, our security solutions architect here at Smallstep. Joining me is Josh Drake. I'll allow him to introduce himself.
Hey folks, I'm Josh. I'm the CTO at Smallstep.
And highest level caster that we have here.
Hunter loves to
So, of
say that. I'm sure the joke is lost on a lot, but I appreciate it nonetheless.
course, let me go ahead and share my screen. Today we're going to be covering ZTNAs, specifically small step solution, super lightweight. We call it enterprise relay, but we do also bolt into existing ZTNA solutions as well. But ultimately, Smallstep is a device identity platform. We focus on enforcing device identity for everything. Effectively, our goal as a company is making sure that you can cryptographically assert that all of your devices connecting to your network, all of your most sensitive resources, are coming from a particular piece of hardware. So historically, we are a PKI company. We run highly available certificate authority services. And in recent years, we've added a new extension to the Acme protocol, effectively to get this functionality to work. The protocol is Acme. We added device attest 01 as the challenge type. And so this allows us to, given an inventory of EK pub keys, so public keys for TPMs, attestation keys for secure enclaves, as long as we have them in inventory, we can do a cryptographic attestation against it. And so only after we've proven that the device has that TPM by doing that cryptographic exchange, do we then issue the certificate to the client. So this protocol works natively in Apple, but we have it working anywhere that supports TPM 2.0. So really any client-side workstations that have been built in the last 8 to 10 years. So problem space that we're solving here is that most organizations use the SCEP protocol, SCEP. It's been around for over 20 years. We consider it super insecure because it is a password-based protocol. There is no proof of possession. So chances are your IT organization is using this today to issue Wi-Fi certificates, VPN certificates. If you're using certificates for ZTNA, they were probably issued via SCEP. And so there's a few problems with the protocol. With password-based protocols, there's no proof that the password was received by the intended device, that it wasn't intercepted in transit and then used maliciously. Assuming it did make it to the device and that device requested a certificate, it lands on disk where it can be exfiltrated by not only hackers, but your end users. So there's very little outside of other compensating controls you might have to prevent that given user from exfilling that certain key, pivoting to their gaming PC over here and using that one instead, because you don't allow them to use what have you and they prefer to. And so this allows us to both limit access from a hardware perspective to your corporate managed devices from a security perspective, but operationally, you're enforcing policy. And so the idea is once we have these certificates down on devices, we can use them anywhere that supports TLS as authentication. So use cases tend to be Wi-Fi and VPN. Again, today's topic is ZTNA, but a lot of identity providers tend to support certificates as an additional factor. And so anywhere that you use Acme tested credentials as these certificates, your device becomes that implicit second factor. So no more Okta Verify, no more Authenticator app, no SMS codes. Your users can just single sign on without leaving their device, without leaving their authentication flow. So security improvements there. It really adds a huge degree of protection from phishing in these single sign-on flows. Another common one we're seeing come up is cloud APIs and cloud CLIs. Same deal, they tend to support TLS for authentication. And anywhere we use these, you become virtually unphishable. So the solution involves a couple things. Step number one is a trusted inventory. So our solution helps you build that. This is required to do device attestation. And then from there, it's a matter of issuing the certificate down to devices. I hope this all comes across concisely. If you have any questions, thoughts, want to dialogue here, we have I lost the button here, but we have a Q&A here down in the chat. So devices are in inventory. We need to get them credentials. We're going to use the Acme protocol. And so, as I said, the Apple ecosystem by default supports this protocol for certificate issuance. It can function on its own as an Acme client. And so any MDMs that it is enrolled in where it supports the Acme payload, or I suppose you can push down an Acme custom mobile config, that's all you need to do. You would just push down an Acme payload via the MDM. The device would use it to issue a credential from Smallstep. And then from there, it becomes hardware bound, key attested, usable in whatever flows you might need. And so the MDM controls certificate issuance, renewal, while the key still remains bound to the device. This direct flow only works in the Apple ecosystem because, again, Windows, Linux, Chrome OS don't natively support it. So to address that problem, Josh and our core engineers have been working on our agent.
All right, thanks, Hunter. Yeah, so as Hunter mentioned, there is native support for Acme device attestation in the Apple MDM protocol. The Acme DA protocol is around 3 years old now. Very shortly after standardization tracks there, we saw adoption from the Apple ecosystem. And while we pounced on that pretty early by adding that support to both our CA technology and providing attestation services within our core platform, we knew right away that this is the direction that the industry was going. And so we saw an opportunity to develop this functionality across OS. Apple used our technology to validate and verify these enrollment use cases. And we see other platforms doing the same over time, but we really wanted to get to a state where we could support this across the common IT landscape, right? So what that meant was that we developed a piece of endpoint technology software. We call that the Smallstep agent colloquially. And what this provides is effectively cross operating system support for Acme device attestation. So in the same way that you can do this natively within the Apple MDM and protocol ecosystem, you can also do this on Windows and Linux and other platforms even, anywhere where there's a secure module available. So as Hunter mentioned, this means TPM 2.0 chipsets, or any other trusted execution environment where there's a cryptographic identifier or a hardware attestable identifier available. That's what we leverage. Hunter mentioned the trusted inventory. That's what your inventory becomes, is devices. I mean, Hunter can show the screen again if he wants, but the device inventory is a combination of those attestable identifiers plus other information that we're syncing from your MDM platform or information or telemetry that we're collecting on the device using our agent endpoint software. So getting back to cross operating system support, again, the enrollment workflows here, similar to MDM enrollment workflows, we're trying to minimize any of the friction or eliminate any of the friction for these enrollment workflows because these IT operators are focused on delivering the use case at hand. We're talking about delivering ZTNA type functionality today, but this applies to any of those last mile type problems, Wi-Fi, traditional VPNs even, but many times we're also working with customers that are doing this to secure internal web apps, or as Hunter mentioned, infrastructure like cloud ecosystems. So our endpoint software is a small little piece of software that runs again without any intervention, both deploying through the MDM channel traditionally or installed in whatever mechanism is most convenient for your IT teams. And this automates the enrollment and certificate issuance against the hardware modules on those platforms. As well, we have many integrations that we support both for configuring. Linux comes up a lot. We'll focus today. We're going to do a demo on Mac OS. But there are cases where it's challenging to manage some of these last mile problems or workflows on these devices. Our endpoint technology also helps with that. We integrate in various ways. Fundamentally, though, we provide a base level integration that's native to each platform. So when we're talking about issuing credentials that obviously are intended to be used by pieces of client software, we make those available through native keychain or native certificate stores on macOS and Windows, and then we provide common conventions for things like Linux, such as PKCS 11 or integration with OpenSSL libraries and things like that. Again, the focus being on doing as much as we can to enable those last mile integrations. In some cases, we even support like automated configuration of those resources, such as Wi-Fi networks on Mac OS, Windows, and Linux. Um, so let's keep going. Again, as Hunter mentioned, we have a Q&A section. I love getting into the weeds on this, so if there's any questions, feel free to chime in, and I'll do my best to answer those. I think we're ready for the demo now. So, like I said, we're going to demonstrate what we call our enterprise relay. So there are some really interesting bits to this. Some of the underlying technology is really compelling. This is most folks on this call attending today or watching are familiar with traditional VPN technologies. Modern VPNs, if you want to refer to them that way, typically support some form of what were commonly called SSL VPNs or TLS-based VPNs. So we've come a long way in 20 years. Traditional VPN software has evolved to support more robust authentication protocols and methods. What we're going to show today is quite a bit different than traditional VPN technology. So there are interesting things fundamental to our enterprise relay. It's based on a protocol called MASQ. It's a slight misnomer, but MASQ is the working group if you're looking for information. This is MASQUE. But there's some interesting protocol specifics there. It's based on the HTTP protocol ultimately, but this is a modern, robust protocol that enables some really interesting ergonomics. You've probably seen or been interested in the ability to do things like per origin tunneling or per origin traffic shaping, things like that. This is all built in natively into the MASQ protocol. In fact, Apple even has support for this. You may be seeing things like iCloud Private Relay. That's based on the same underlying technology. Our enterprise relay is similar in many ways. It's the same underlying technology, except ours, again, works cross-platform. So we're going to show today a native enrollment or a native demonstration on macOS, but similar to what I was referring to earlier, the Smallstep agent provides that cross-platform integration on Windows, macOS, and Linux. Okay, so how are we going to demonstrate this today? So there's a few things I want to point. Let's see if this graphic is doing justice here. We're going to here flip back to the graphic real fast. I don't want to. What we're going to do today is run through a credential issuance. We're going to issue a credential that's authenticated through the Acme device attestation protocol. The resulting credential will be bound in the hardware. We're going to demonstrate on macOS. That means it's in the secure enclave. And then we're going to use that credential to connect through our enterprise relay. Again, you can see this through the graphic with a browser to a destination. Now, someone can, I'll try and communicate the link. You're free to play along here. We have a simple demo website that's stood up that simply limits inbound traffic to a specific set of ingress IP addresses. When we provision an enterprise relay for our customers, what that means is you get a set of, well, we're going to call them proxies, but effectively instances, compute instances running wherever the customers need them to be, giving you a stable set of IP addresses that you can use to configure any SaaS app, really, or any internal network. So whatever really you want to do. But the enforcement mechanism there for the resources that we're allowing traffic from a known source, the known source being our enterprise relay. So by authenticating through the enterprise relay and then having traffic be relayed through that, we can guarantee that any traffic coming in through those stable IP addresses has been authenticated in the way we want. As you can probably expect, and mentioned here on the slide, we're authenticating using mutual TLS. What that means is the credential that we issue using Acme DA is used to perform a TLS handshake, no different than if you were to go to any website secured by TLS, except that we're presenting a client certificate, so which is why we call it mutual TLS, the client certificate being the one we'll kind of demonstrate here shortly. Um, Again, this applies cross operating system. It's very, very similar to so some. There's a question in the Q&A section, which I'll again, questions are great. I'll try not to get too in the weeds, but this is very similar to iCloud Private Relay. The underlying technology is the same, except this is like your own Apple Private Relay, your own iCloud Private Relay. This is for you, for your organization. Apple developed iCloud Private Relay primarily as an anonymization technology. This is something that you can use to anonymize both source and destination traffic. And in fact, it uses a double relay system. The first obscures the destination, and the second obscures the source. But again, that was intended for kind of a different use case. Our enterprise relay is like you're having your own iCloud Private Relay. Yeah, great question. If there's any others similar, feel free to pipe up. But as I was mentioning, this works cross operating system, and for any use case in which your enforcement point or which your resource can be configured to have something like an IP allow list, which is a lot of SaaS apps, turns out. Okay, so we're going to jump into the demo. Like I mentioned, flip over to the next slide. Here's roughly what we're going to do. And I'm going to go through it at a moderate pace. Again, if there's any questions about what's happening under the hood here, feel free to let me know. But if you use an Apple MDM today, you can do this in conjunction with Smallstep. You could ping Hunter right after this, and he could get this set up for you. So first, we're going to issue a credential using the Acme certificate payload. I'm going to refer to some MDM payloads. If there's any questions about those, you can obviously find the documentation on Apple's website. But we're going to show using those payloads. I'll show some of the configuration that comes out of that. But we're going to issue a credential. We're going to configure the relay. And when we do that, we're using Smallstep managed CAs, and we're using Smallstep's enterprise relay when we do this. And then, like I mentioned, we're going to do mutual TLS through that relay to access a protected endpoint. And then we can talk a little bit about what this means for you and your teams and how you might be able to operationalize something like this. Probably coming from a similar environment where you might have traditional VPN technology, even stuff that's using certificates, and talk about some of the benefits of adopting both this issuance workflow, but potentially even the enterprise relay technology. All right, I'm gonna start piloting on this Mac I have over here to make sure I don't unplug thing as I do this. Okay, I'll confirm with everyone here that I have to share my entire desktop here, so bear with me. Okay. All right, that looks good. So here's our starting point. Again, we have a small little demo website. Feel free to navigate to this on your own. You should see exactly what I'm seeing here. Again, we've configured this. This is simply just a static website that's configured to only allow traffic from certain ingress IP addresses. One of those ingress IP addresses is the relay that we have set up. Again, you can have multiple relays. Let's say you have a geo-distributed organization where you have some folks in North America and some folks in Europe or Southeast Asia. We can spin up relay instances all across the globe to allow low latency between end user endpoints and the relay itself to the traffic destination. So today we have just one, and so we have a single IP address that we've allowed traffic in from for this static IP address. Now, I'm going to start by I'm going to show a few things, but let's start from the basis. I have two IP identification websites up here, and I'll say why here in just a moment. But this is my home IP address. Don't do anything malicious with that, please. But here is my home IP address. And now I'm going to show a configuration profile that we have pushed out through Jamp. I have the relay. I'll come back to this in a moment, but I have the relay off. That's important. Okay, so here's what, again, a simple profile for this looks like. You can do this today, again, if you have an Apple MDM. We have the Acme certificate we talked about. This is using a managed Smallstep authority, and it's using the Acme device attestation protocol. When this certificate is issued, the hardware itself is attested. You get the highest guarantee possible that the device is a genuine Apple device and that the device is who it says it is. It's trusted within your inventory by way of synchronizing those devices from your MDM or some other trusted source. And the attestation that's generated by talking to Apple servers and communicated to Smallstep servers is validated both that the attestation is genuine and also that the device is in your inventory. The only way that you can obtain these credentials by having all of those checkboxes met. This is how we build what we call your trusted inventory of devices and how we base issuance workflows off of that. Okay, we have a few other things in here. We're trusting some root certificates. Again, we need that so that we can both communicate to the CAs, but also our relay itself has a server certificate, and so we're trusting how that's being issued. And then finally, interesting thing, if you're interested in ZTNA technology, is this relay. Again, you may not be familiar with this. I think support was added for this. Oh, geez, I think it was roughly 18 months ago now, and so this is a relatively unknown capability both on Apple platforms themselves, but also in the MDM protocol. But yes, we have our relay configured here. This is the relay that I've set up ahead of our demo, our webinar today. Okay, I can show more about this relay. Again, this is all integrated into the Apple settings. You can force this to be on all the time. Obviously, I want to be able to turn it off so I can demonstrate the capabilities here. But here is what our relay configuration looks like. This is mostly self-explanatory, so forgive me, but we have a server. This is what you get if you asked Hunter this afternoon to set this up for you, you'd get the server URL here. We provision that for you at Smallstep, and then you tell us what you're trying to secure. We're doing two websites here. This is why I have two of those IP identification websites. I have one where I'm going to navigate to icanhasip.com, and I'm going to show it. What should happen here is traffic will go over the relay. Again, that connection will be authenticated using my Acme certificate. And then I should see the IP address of the relay. It should be different than the one I just showed. It should be different than this, my home IP address. Again, don't do anything malicious with that. And then I also have the demo website here. So again, that's the website that's over here. You can kind of check in the URL bar and then refer to this. So it's simple. There's a lot of configuration options here. Again, native to the Apple protocol. You can do wildcards. You can do all sorts of stuff with it. The same capability and tech and functionality is available in our cross-platform capabilities. So the Smallstep agent kind of mirrors the capabilities that are available natively in the Apple protocol. It achieves the actual relaying with the relay still, but slightly different on device technology. We can talk a little bit about that more if we have time. Okay, so there's my relay configuration. Again, I'm refreshing in the browser. You can see that I can't access the website. You can see my IP address is this IP address. Now, what I'm going to do is I'm going to turn the relay on. Now, I do have to restart Safari here. That's actually one of the things that the Smallstep agent software mitigates. Again, this is new in Apple technology, and so this is still not like I would say Safari will eventually pick up that the relay is turned on and make changes. There's a small bit of operating system like low level I'm going to say caching, but there's a bit of low level caching going on here that forces us to have to restart the browser. So I'm going to go ahead and do that. I'm going to restart Safari, and I'm going to start Safari again here. This works in all browsers, but I'm just showing it Safari today, just in case. I wanted to open up those well, here, let's go down the line. Okay, so remember, I had Icon has IP in the relay settings, right? So if I go back into the relay settings, you can see now I'm getting the relay IP address here. If I navigate to this other IP identification website, you can see I still have my home IP address. And then finally, spoilers, you saw probably when I flipped through it. Now I can access our demo website. That's it. It's that simple. Most folks are familiar with how IP allow lists work, so I hope that came across pretty straightforward. The interesting parts there are, like I mentioned, the fact that all traffic coming from that ingress IP address or egress IP address, depending on what part of the what end you're coming from, is authenticated using mutual TLS, using that Acme certificate I talked about. What you can, the guarantees that you can make in downstream systems, like let's say you're protecting internal web apps here, are the highest possible guarantees that you can provide that this hardware is both trusted and in your inventory. You might be, we're getting into the territory of kind of how this is improving upon existing, VPN or ZTNA technologies. Like you might be using X509 certificates in your VPN or your ZTNA technology today. But I'm going to say improbable. I would love if someone I love hearing about it. If someone says otherwise, but it's improbable you're using hardware-bound credentials, and even less probable that you're using hardware attested. Again, the device itself that is cryptographically attested. There's a lot of benefits to having hardware credentials. Hunter mentioned a few of them, right? It's providing a level of security or posture that you can't get with any other approach. Like those credentials can never leave the hardware. There's a bunch of downstream ergonomics you can think of here. Like, for example, you can build workflows around this, knowing that those credentials can't be exfiltrated. You can increase session lengths of things. You eliminate entire attack vectors from your landscape. And especially as attacks are becoming simpler. We have AI coding assistants and AI technologies that are increasingly um, multiplying the amount of attacks being produced and produced more rapidly. So fundamental security like this, security that's based on unbreakable cryptographic proof over the device. Again, some of the basis of trust or basis of security you might be interested in employing at your organizations. So we feel like sophisticated or forward-thinking organizations are the organizations we've talked to most about this. They're implementing things like what they might call hardware-bound device identity programs. But again, these organizations are looking for the strongest possible guarantees that the devices they own, they know about, they trust, have the strongest possible assurance when they're authenticating in these kinds of workflows. All right, I think that wraps up my little demo. I'll stop sharing. Again, I think we have time for about 10 minutes of Q&A. Is that right, Hunter?
Give or take.
Yeah. So we're happy to field any questions.
While we wait for them to come in, Josh, curious if somebody were to try and replace your VPN architecturally, what would that involve?
So there's going to be some variance, right? Most of the time, people are using something like a traditional VPN as a perimeter. That's the most, I would say, the most common operational mode is the VPN performs acts as a network perimeter. You're doing the same thing here. Now, the small step relays can be run again, managed by small step and deployed anywhere you want, and you still get that network perimeter. But the other thing you get is actual authentication of the devices. So it's not just that you're creating a boundary around those protected resources. You are actually performing zero trust type activities to allow that traffic into your network. I'd say in most cases, there's a straight up lift and shift possible for traditional VPNs to something like this. You might be using a ZTNA too, and ZTNA may have more sophisticated policies, and that's totally fine. We're not looking to replace sophisticated ZTNA technologies. The Mentor mentioned this early, but the small step enterprise relay is intentionally a lightweight a lightweight solution that we intend to be, even in some cases, a progression from more legacy technologies like traditional VPNs. In the same way that, like I mentioned, you may be using credentials today, X509 certificates, even for securing your VPN or securing your ZTNA, and that's great. In the same way that we just used a hardware attested credential to access the enterprise relay during the demo, you can do the same thing with your existing technology stack. So if you are just really attached to your current ZTNA technology, that's totally fine. In most cases, small step can still be the thing issuing the hardware attested credentials, and you can utilize those. There's no necessary need to move to the enterprise relay. That's a vehicle for demonstrating the core technology here.
Perfect. Here's a good one.
Yeah, let's see.
Why mask?
Why mass? Lots of, I mean, performance is a big one, but also it very simply allows for some of the primary benefits that we see desirable in that space. The big one is there's a few, but DNS over HTTP is natively supported. So DOH, you may have heard of this, that allows for resolution of hosts from the relay itself. It allows you to make more sophisticated network topologies that fit your requirements. And then native per origin traffic behavior, right? So a very, very common complaint. I mean, depending on the audience, I'm sure folks have been in an environment where when you had the VPN on, all traffic was going through that VPN. Not only is that a concern for a lot of end users, it's also highly unperformant. So in modern history, even the Apple MDM protocol has some capability for doing per origin, or what I think what they call it is like per app tunneling even. That's native to the protocol here. So you get that out of the box, and that's a pretty killer feature to kind of supplant what otherwise might be a pretty dissatisfactory overall architecture that you might have today with the legacy technologies. But again, the big one is performance. It's based off of HTTP3 and UDP, and so you get some really great performance benefits out of the box there. So normally no. I did today. When you turn on the relay, like I did during the demo, yes, Safari has to be restarted. Now, again, I want to mention that when you're using the Smallstep agent to do this cross OS, even on Mac OS, that's not the case. But remember that you're typically going to deploy this relay and not allow users to turn it on or off. And so, yes, you'll have to do this once after you initially deploy this, but never after that. So you may have to do this alongside a scheduled. May want to deploy the profile strategically along a scheduled update or something like that, knowing that the device is going to restart or the browser is going to restart. But otherwise, after the relay is deployed and turned on, you won't have to. I had to do that today because I was demonstrating. I was manually turning it on and off. And again, that's not the case when you're using the Smallstep agent software on these endpoints. Hopefully that helped.
Perfect.
Okay.
So I don't have any other questions if nobody else does.
Yeah, I think we covered a lot of the benefits too, and hopefully covered some topics that maybe people were thinking but didn't otherwise feel like they could ask. Again, I think that a Small Step as a platform speaks to a lot of the, like I mentioned, the forward-thinking organizations and organizations that really are looking to have a more robust strategy for managing their IT user endpoints. If you're interested, again, feel free to reach out. We're happy to do. We do really rapid validation of these kinds of technologies, and have really slick ways of kind of demonstrating the value proposition quickly. So hopefully we'll hear from some of you folks shortly.
Yeah. If you have any questions, want to reach out, you can communicate with us directly. So I'm Hunter at smallstep.com.
Yeah.
We have sales at smallstep.com if you'd like to talk with an account executive. If you need support at smallstep.com.
Yeah. And if you
And
really want to get in the weeds, you can always email me. I'm Josh at smallstep.com.
so I wasn't going to volunteer that, but perfect.
Hey, I love a good spelunk. That's okay.
Yeah. Josh, a little off topic, but what's
Yeah.
anything you're working on right now that you're excited about?
Let's see. What am I working on right now that I'm excited about? I think the thing that I'm most excited about, we recently launched support for Chrome OS. So Chrome OS, Chromebooks in general, have TPMs in them as of like 6 or 7 years ago. And this is leveraged to some degree, but we recently launched native Acme device attestation for Chrome OS. And so if you're using Chrome OS and you have Google Workspace, we integrate natively with Google Workspace. Maybe you're using Chrome devices for call centers or support agents or whatever it is. A lot of organizations have these as like really low cost, low friction devices for single task users. And so what that gives us is the ability to reach into that Chrome OS and Google Workspace environment. We developed a browser extension to provide support for that, and it works seamlessly. It's a really nice way that we're extending our cross OS story. I'm super thrilled with that. I'm super happy with the work there. So if you're interested in anything around there, like I said, Chrome OS related, let us know. We're also working on native clients for Android. Again, the iOS platform already supports this, but we're working on building out our BYO story more. So we'll look forward to seeing more from that, more on that from us later this year.
Thanks, Josh.
All right, thanks,
Great
folks.
here today. So you know how to reach us, everybody. We look forward to seeing you next month. Okay. Have a good
Yeah.
one.